India passed the landmark nuclear law, Shanti, acronym for Sustainable Harnessing and Advancement of Nuclear Energy for Transforming India in December 2025, opening the doors for private players to invest in the nuclear energy sector in India. Many big international players in the nuclear energy sector have shown interest in investing in India's nuclear sector since the Shanti law was passed. One such private player with ambitious plan to build small modular reactors in India is a US-based nuclear technology company, Holtec International. Today, we have with us Holtec International Chairman and CEO Dr. Krish Singh to talk to us about the plans the company has to expand into India's nuclear industry, the future roadmap, and other issues. Welcome to the print, sir.
Thank you. Thank you, Ms. Daskutta. Yes, it's a pleasure to talk to you.
Thank you, sir. Without wasting any more time, sir, I would want to ask you that if you can tell us about Holtec's manufacturing plans in India, now that India has a nuclear law in place that allows private players to invest in the nuclear energy sector.
Yes, the Shanti bill, and Shanti, by the way, is a very appropriate name. Shanti stands for peace, doesn't it? Yes, yeah. I think it's a great name. It's a very significant development in India's energy policy. Is by far the most important legislation I have seen in a long time in India. We have been pushing for it, as you probably know. We have been pushing at every level in the country to open up the design, manufacturing, licensing, construction of nuclear power plants, particularly SMRs, small modular reactors, as soon as possible. And we think that is the way for India to begin to introduce nuclear energy at scale throughout the country. SMR is distributed generation, meaning that the reactors make relatively small amount of power, 300 megawatts in our case, and you put them, the goal should be to put one in every county, every district in the country.
Basically, localized grid applications.
All right. So you don't need expensive grids to carry power. You're not relying on weather problems that sometimes bring down the grid. So it's the way to do it. And our SMR, I'll tell you later if you're interested on why it fulfills those needs. But speaking to your question about manufacturing
and plans for India.
Yeah, the manufacturing, we are working with the US government to get authorization to manufacture in India. We are also looking to get authorized so we can Indianize, if that would be the right word to use, the reactor so it is more suited for India's conditions. Okay, and that's part of the request we are filing with the US government. So our team in India will be looking to take our SMR 300 reactor and Indianize it to basically preserve all the safety features, but bring down the cost. It is difficult to explain in the framework of a short call, but I can tell you that it is possible, and it will make the reactor more affordable. And we have to keep in mind the energy cost is a critical cost element, and we have to be cost competitive. But we will manufacture in India, and our plans are currently, you might know, we have a manufacturing plant in India now. We have in Dahej in Gujarat.
Gujarat, yeah. You have a condenser manufacturing unit there.
Yes, and we plan to build another plant soon, someplace in that part of the country where we will make other capital equipment for nuclear plants. Uh, they actually, the equipment can be used in nuclear plants as well as in commercial power plants. It's a dual purpose equipment. We plan to be building it, and then we'll build more. I know we're talking to Larsen and Toubro, which is, you know them, they are Indian top manufacturers, to build some facilities with them to add capacity in their existing facility so we can build more. But we understand that just bringing a design is not going to be adequate. We have to manufacture, particularly for India, it is more important because we can take advantage of scale.
Right.
Hundreds of SMRs can be built in India if we build them economically.
So I was reading somewhere that Holtec is planning to build 200. They plan to build 200 SMRs in India. Is it correct?
I think that's a good, modest goal. If you consider that India has 600 districts, if you put in 200, you only cover 1/3 of it. So I think it's a good goal, but talk is cheap. The important thing is to understand the challenges that lie ahead. And it is not going to happen by waving a magic wand.
Right. And it's also not going to happen in a day or in the next 5 years. It's going to take time. So in fact, I was coming to my next question, which covers this. But before that, I just wanted to ask that last year, Holtec had got clearance from the Department of Energy to transfer some technology and to work with Indian companies. So now what is the next step? I mean, before you actually come to India?
The authorization has been too restrictive.
In US?
In the US authorization is too restrictive. And it is very, very difficult to normally do business under the current authorization we have. So we are filing or have filed, can't be sure, an amendment to the authorization that will allow us to do things we want to do at scale. Our plan is to have add hundreds of more engineers in India, in our nuclear area. India doesn't have an adequate number of nuclear engineers right now because the economy has been closed, nuclear economy. It needs to be built up. So we are proposing to the Indian government through partners in India that we develop academic institutions, nuclear programs in different IITs and other institutions that focuses on nuclear small modular reactors. Run some trade schools that teaches nuclear manufacturing.
Basically, develop the requisite manpower when all these companies come and start investing.
Develop the infrastructure so that we can build. We need to have a nuclear quality assurance program, which is very different from a commercial program. It is more akin to manufacturing for aerospace. Aerospace manufacturing requires a similar level of quality. We want to introduce that into India, and we're going to take our U.S. reactor. And as I said, we'll Indianize the design so it will be built locally, except for those parts that can be supplied from the U.S. We're gonna bring equipment from the U.S. where it makes sense, and we will manufacture domestically where it makes sense. But I look at India and U.S. to collaborate in a way that is win-win for both countries.
Right.
And so I can see my way. I can see my way clear through it, how it can be done.
Right. But so what kind of a time frame are you looking at? Like how long will it take for the authorization to come so that you can enter the Indian market?
I'm hoping that all of this will be done in 6 months.
Okay, the next 6 months.
Yes, and we are, by the way, in anticipation of that, we are proceeding. We're doing preparatory work. For example, we are about to buy land to build a new factory in India. We probably have the land in the next month. We are
Which state,
negotiating.
sir?
I, you know, I think it's in eastern Gujarat. I think.
Okay.
I'm not sure. Look, I look at the whole country as one. Wherever the best opportunity is, where the government is most forthcoming, state government, that's where I'll put
Mhm.
it up. I don't have any provincial preferences. It's
So you're
wherever.
looking at buying the land to set up a manufacturing unit.
Yes.
Okay.
Yes.
So, sir, do you think that, SMRs are the way to go? And why? Of course, one of the reason is localized grid applications. And also, because there is a big push to develop the SMR technology in India as well. We have the state-run NPCIL, Nuclear Power Corporation of India, which is working to develop the SMR technology. So, why do you think SMRs are the way to go? I mean,
Yeah.
why this big push for SMRs?
Well, SMR is if it's the right SMR, not every SMR is going to fulfill. People misuse the word sometimes, right? The
Hmm.
idea of the SMR, I can tell you what is important for India and what we have engineered. I
Right.
don't know what NPCIL is doing. I presume they're doing a great job, and there should be multiple competing technologies in the country. It should not be just one design.
Hmm.
That you end up with cars that look like ambassadors everywhere, right? You have to have competing technologies. That's how the country benefits the most. I'm not advocating that it should only be Holtecs. We would hope to win the lion's share because we have a better and more cost-effective technology.
Right.
I firmly believe in it. Now, let me explain to you why SMRs are important for India. Necessary, actually. First, in a large country, which is from nuclear standpoint so underdeveloped,
Yeah,
it
we just have
is
8 gigawatt of
you have
nuclear
to
energy right now.
and we have to get up to 100. So we got 8 megawatt in the past 40 years of nuclear construction. And in the next 30 years, we want to build 100
100
megawatts. So, of
gigawatt.
course, it's a dramatic increase. And we can't realize that increase unless we can make these reactors uh,
Hmm.
standard. So you can put the reactor in in the Deccan Basin or up in the northeast, in the north where earthquake activity is much stronger.
Hmm.
Tectonic plates are more active. You can put it any place in the country. It should be a universal design that fits everywhere. That's
Right.
one. That's very, very important to realize cost improvement. The second piece, the reactor needs to be designed such that you don't need a large exclusion zone outside the
Hmm.
reactor's perimeter because India is a well populated country and you can't give up a kilometer.
Land is a issue.
And an issue. Our reactor with two reactors together, we build them in pairs. You have 600 megawatt output electric.
Hmm.
600 megawatt takes up about 30 acres. 30 acres.
Hmm.
Outside the 30-acre perimeter, you can build apartment buildings
Right.
because if you postulate the worst possible accident, radioactivity will not affect the people who are out there right outside the plant's perimeter. So designing it so the land requirement is most compact is very, very important. So I
Hmm.
gave you two reasons. One is you produce en masse, single design, produce them in large numbers, and the other one is radioactivity should be confined to the plant, regardless of what kind of horrible accident you postulate.
But sir,
Okay.
there is a safety aspect to it because if a building, say, I mean, by virtue of the fact that they are small reactors, you will also have a large number of reactors, 200 reactors, SMRs. So there is a safety aspect involved also, which needs to be taken care of, which needs to be, addressed.
Yes, the reactor, yeah, you bring up a good point. You bring up a very good point. The reactor needs to be safer
Right.
than any installation you can walk into in the country. You know what I mean? You can go into a building, an office building, or you can walk into the reactor. You are better protected in the confines of the reactor than you would be in an office building, any place else. That the level of safety is paramount. And the way we have accomplished that in our reactor is step back for a minute. Look at all the accidents that have occurred in the past, in the history of nuclear power. Every single time, it's a pump, a motor that failed, a man made equipment that failed. At Fukushima in Japan, the motor got wet from the tsunami and they could not run the power. They didn't have any power. And the plant, of course, then the fuel was heated uncontrollably, created a big accident. The man-made equipment is the vulnerability. So what we have done in our reactor, if there is any accident, the safety recovery system does not need any pumps or motors. It runs on gravity, It's like if you stand on the roof of your building and you have an apple and you drop it, it's going to fall, right? It's not going to go up in space, correct? Gravity always works. And if you design your systems, and there are clever ways to do that, then you will never have the problem, a risk of something not working. Recovery from an accident will be guaranteed. That is how we have designed our reactor. Now, if NPCIL also does it, wonderful. Then we'll have two competing reactors that will serve the purpose of the country. But we are looking at
the reactors that the reactor technology that they are developing is called the Bharat Small Modular Reactors, BSMRs.
wonderful.
Dr. Singh, Dr. Singh, I also wanted to ask you, because we are talking about SMRs, that the first SMR that Holtec is building in Michigan, it will be ready only sometime around 2030, if I'm not mistaken. So, do you think that it can become an issue in India, considering that, this technology, SMR technology, is unproven commercially? Globally, if we see, there are only two SMRs that have started operation, that are operational.
Well, understand that those, first of all, they are smaller than the small reactors. And second, they are also first of a kind, aren't they?
Right.
So
yes.
the fact that the accident, take any accident, 3 Mile Island in 1979, that accident did not occur on day one. The plant was running for a long time. So the fact that a reactor has been started doesn't mean that it's going to be a guarantor of safety, right? It is. The nuclear regulations are extremely rigorous. They're extremely safe. And the weakness in nuclear reactor, in water-cooled reactors, not the liquid metal and others. I'm not speaking to them. Water-cooled reactors. The weakness in water-cooled reactors are known. We know them what they are. And in the SMR design, we have eliminated those weaknesses. I'm not sure what the Chinese have or the Russians are proposing, but I would submit that our attention to safety is paramount. That is what governs the reactor's design. You could not, an engineer could not find a weakness in the system as it is engineered. And that's what the regulators do. They review it. AERB, the India's
Atomic Energy Regulatory Board. Yeah, yes, of course.
I would expect them to review it in depth, just like USNRC is reviewing our application. But all I'm telling you is that having a reactor running right now with no guarantor that it will be safe 10 years from now, None of
Yeah,
these
yeah.
reactors have failed in the first week. They have
Mhm.
failed in the past after years of use.
Right. Also, is Holtec in a position to arrange for fuels also when you come to India? Like, how do you plan to source the fuel? In this case, uranium.
Mhm. Well, fuel suppliers now there are multiple sources, and India now is a member of it's no longer ostracized. Like
Hmm.
123 agreement was signed in 2008, and there are multiple suppliers of fuel pellets. We have
Hmm.
partnership. We have a strong partnership with EDF France,
Hmm.
and we buy fuel from Framatome, which is another French company
Hmm.
that works with EDF. Uh, we don't see any problem ensuring
In
a
sourcing the
supply.
fuel.
Yes, and over time, once we get our reactors going, then we will build a fabrication plant in India in collaboration with a suitable partner such as EDF, Framatome.
Okay.
There are others too who are interested. Uh,
So, sir, right now you have tied up with L&T, Larsen and Toubro, but I mean, are there any other private companies in India with whom uh, Holtec has tied up?
we have received U.S. government approval to work with Tata Power
Hmm.
and Tata Consulting company. I guess there are many Tatas. But this is a Tata Consulting company,
Hmm.
and Larsen and Toubro. They are the ones who are listed. We have also we are applying for NTPC as the owner operator,
Hmm.
prospective owner operator, as a partner also. And there will be others. We will add them, but we don't want to go and sign up a lot of companies
Hmm.
without the assurance that they are really serious. They're willing to, put up the funds and resources to be building these reactors. So we're being very selective. We know NTPC is very, very interested
Hmm.
based on our conversations with their leadership team. Uh, NPCIL is self-sufficient. They
Yeah.
don't need to. They don't need to Holtec, I don't think, to help them. So, and I wish that they develop an excellent reactor. I'd love to have some worthy competition in the country.
Right. So, sir, Holtec plans to manufacture SMRs in India and then, have some kind of a tie-up with state-run companies like NTPC to run those plants. Is that the model you are looking at?
Well, running the plant will be a specific deal. For example, I'll give you an example. A
Yes.
user, a consumer of power, that could be a Reliance or Adani Group or what have you. They can be the owner, and we can operate the plant for them. I
Okay.
mean, we will run the plant turnkey for them if they ask. We
Okay.
have the capability to do so.
Hmm, hmm,
Uh,
hmm.
or they can hire NPCIL to do it. They should be free to hire whoever they think will do the best job for them. I'm a firm believer in a free enterprise. I think if they give the owner options, the best outcome will come out of it.
Right.
If you got to give them the option, we don't want to be. I detest monopolies. I think that is wrong because that takes away the spirit of innovation, the
Hmm.
spirit to keep yourself, make yourself a more productive organization. We're not looking to any privileged, unique position in India. All we want is a level playing field and open markets. I just give you a comment. You have not asked a question, but I'll tell you the Shanti bill does not say how much private ownership. Does not say,
Yeah.
but I have heard that the guidance will say 49%. And from 0% to 49% is great. But
Hmm.
in my opinion, that's a mistake. The government should allow any qualified party to come and build the plant. if the Emiratis, UAE people want to come in India, invest the money and build, why not let them build? What is wrong with it? It is not a it's energy producing enterprise. It is not a defense, a production item. So you let them. There should not be a limit. U.S. doesn't have a limit.
Yeah.
If the countries don't need to, I'm negotiating with countries in Western Europe. They are perfectly willing to let me own and operate the plant. There's no problem, and India should do the same. I think.
Maybe so because they have just opened up the sector for private players. They're trading a bit cautiously.
Yeah, understand. The controls, the controls to ensure that the private enterprise behaves with utmost sense of responsibility, looks after public health and safety. Those things the government, of course, has to have. But you don't do that by becoming a stockholder. You do it by being the invigilator, the controller. Ensure that the plant is being run to the highest standards and no corners are being cut for profit shake. But that the government can do that without being a stockholder,
Right. Sir, how much time do you think it will take for the Indian regulator, the Atomic Energy Regulatory Board, to clear the Holtec SMR design? I mean, how much time do you expect it will take? And also, I'll ask the second question with this: that have you started any discussion with the Atomic Energy Regulatory Board? Have you submitted any documents to ARB?
Yeah, we have not submitted any documents yet, and the early discussions will begin very soon with them. How fast they would be able to approve depends on how well they are resourced. If the government gives them enough resources to conduct a thorough review that they must, then it will be delayed. If the government supports the government entity, right? If they are properly resourced, I think they have a great leadership from what I hear. The people, the individual running the AERB is a very capable person. We just have to make sure that he gets the necessary resources from the government to be able to do it. Trump here in the US, he told basically the NRC that you must complete your review. I guess 12 or 18 months, right? It's kind of a soft directive to the regulator. I think that Prime Minister Modi is capable of doing the same thing, setting down the rules and say, hey, get it done. But then it's necessary that the agency has the necessary resources. They should not be doing, I would be the last one. I'll be the first one to state that do not shortchange the regulator. Make sure that they are fully resourced to do a first-rate job. Because if the regulator is weak, then the public will lose confidence.
Right.
And then that will be the end of the program.
Right.
No?
And that would defeat the whole idea of bringing this new nuclear law. Also, so another thing I wanted to ask you is, in India, when you're coming and setting up SMRs, one of the constraints rather would be water. Because unlike SMRs are small reactors, so are you kind of geared up to provide the SMRs with the air cooled condensers? Because Holtec has a specialization in air cooled condensers. Globally, nowhere does a nuclear reactor comes with air cooled condensers, because of the simple fact that the nuclear power plants are near coastal areas where water availability is not an issue. But there is a shortage of water here, and when you're looking at that kind of scale, how do you plan to address it?
Yeah, first of all, yes, our SMR 300 reactor can be equipped with air-cooled condensing. So the amount of water needed is very, very little.
Yes.
You can do that. Now the effect is the output will be reduced a little. Okay.
Oh, okay.
There's a little reduction in output, and there's a little increase in cost because air-cooled condensers take up more land, they cost more money than the water-cooled condenser. So there is a as engineers say, second order effect. You have an increase in cost and land area, but it's a practical way to do it. And I would suggest that it be the model instead of relying on water supply. Use water for other purposes like irrigating land and other things. The nuclear power plant should not be running on water. And I understand that the government has that policy now. They're asking operators like NTPC to convert their fired plants using air cooling. I think that's an enlightened policy that should be pursued.
Yeah, because even NTPC, sir, which is scouting for land to set up nuclear power plant. I mean, one of the constraints that they are also facing is water. And in case of SMRs, because there will be inland locations, so water will be an issue.
Yes.
Apart from water, sir, what other challenges do you foresee you will face in India?
Well, technical challenges. Water is a technical challenge, right? The other technical challenge always is risk of earthquakes. So we have designed our reactor that you can put it any place in the country, maximum earthquake, places that are most seismically active. You can put the reactor and it will be qualified for the earthquake. My recommendation is that AERB only approve reactors that are qualified to 0.5 G, 0.5 times the acceleration due to gravity as the earthquake requirement. That will cover the whole country and be one design for the entire country.
Okay, got it. We'll move a bit away from SMRs and nuclear technology and talk about you, sir. You are an Indian entrepreneur in US. Tell us our story. I mean, how did you? When did you go to US? How did you, go about building this company, Holtec International? How was your journey like?
Well, that question will take a long time. I can tell you a couple of sentences. I came to America when I was 19 years old.
From where?
I came to America after I finished my bachelor's in engineering and a special fellowship, and I was always entrepreneurial. So after I got my PhD, I did some research for a while. Then I realized that this won't have the impact I wanted to have. So I began to gradually move over and eventually founded Holtec. And now I'm living.
Which year was that, sir?
1986.
Okay.
And actually I'm living the dream because what I wanted to do is what I am doing. So
how has the journey been?
Well, any journey in retrospect looks like a lot of fun, but at the time it was a lot of work and a lot of challenges. That's the nature. If you try to do something.
You are a first generation entrepreneur.
Yes. And I guess I would have done the same thing if I lived in India because I'm made that way. I'm willing to take risks, and I rely on myself to do things that many people will shy away from. That's the definition of an entrepreneur, right? So that's been my life. I'm glad I have lived a life that I have. Given a chance, I'll live the same way again. It's been a wonderful experience, and I'm hoping that before my story ends, that I get SMRs going in India, Holtec's SMRs and others. But the country is rapidly building nuclear generation capacity because that is necessary to clean the environment, to eliminate the pollution that's gripping India, and also to create plentiful opportunities for jobs. If you have affordable energy, you will have manufacturing, you will have work.
Yeah. And also from energy security point of view, sir.
Security, right. So that's my little personal ambition. I hope that it happens. And if it happens, I'll be very, very pleased to have lived the life I wanted to live.
Any memorable experience that you can share with our viewers in your entrepreneurial journey in US?
Well, I'll have to think. There have been many, many, many interesting instances.
Something which
Um,
made a mark, which you still remember, or I mean,
but when
hold it.
when I first came to America, it was Indians were not known in this country. I think the number of people from India in the country was in the thousands. Which was not a. I would go to churches to explain to them Indian religions because they didn't know. They did not know. So socially, it's a different country today. On the entire East Coast, I lived in those days in Philadelphia. There was not a single Indian restaurant in all of East Coast except in New York City, across from United Nations. So if you wanted to go have an proper Indian meal, you had to go to New York, okay, to a restaurant. That's the way it was in 1968. Today, they're everywhere,
Yeah, you go
So
wherever.
the country had changed. I mean, I didn't have any access to newspapers. I would go to Indian newspapers. I would go to the Van Pelt Library at Penn, University of Pennsylvania, that would get the paper uh, 1 week late.
Indian newspaper.
Indian papers like Indian Express, Statesman those days from Calcutta, they would come a week later by onion skin paper, real thin paper, and that's what we would read. I would go occasionally to read to catch up, but it's like living on another planet back then.
I started journalism with Statesman, so that was my first job in Delhi.
Is that right? Well,
Yeah.
Statesman is a great paper.
I was there for 4 to 5 years. 4 years, 4 years.
I see. It's a great paper. Yeah. Comes
And
out
you
of Calcutta.
Okay. And you still have family in India, sir? Do you come here?
Rarely. I have a sister, and she is in her 70s, and she doesn't want to live any place other than where she lives. and I see her every few years, but it's been. I've been in India maybe 5 or 6 times in the past almost 60 years. So it hasn't been that frequent. There'll be more trips now if we get industrially engaged, there will be more trips now.
But which part of India you come from, sir?
I was born near Patna in Bihar.
Okay. So before we end the interview, sir, one last question. So Holtec is also renovating Palisades, a 800 megawatt reactor, which was shut down in May 2022. And this will be the first time a decommissioned nuclear plant will be restarted in US. So can you tell us more about it? When is it expected to start commercial operation?
The plant is on the verge of commercial operation, but there are challenges that we didn't fully appreciate when we started this restart program. For example, equipment parts that were available 50 years ago are no longer available. So you have to reverse engineer and build replacements. And we did not want the reactor to be restarted with old parts that may in a couple of years fail and bring the reactor down. So we have an ambitious program to literally renovate the whole plant. And that means thousands of parts that have to be replaced, many that have to be, as I mentioned, re-engineered because they're no longer available. We are in it. And people, they tell me that right now, our expectation is that by mid-April, the plant will be up and running. It will be lovely to see the plant up and running because it's costing us $1.5 million per day.
Oh,
Yes, dollars per day, every day that is delayed. So, yeah, I'm waiting anxiously to get the plant up and running. It will run for 30 years. And it will be a significant source of revenue for us. But right now, it's a big drain.
okay. But so that would also maybe open doors for other such plants which are old nuclear plants, uh, which have been decommissioned or likely to be decommissioned.
Yeah, we have blazed the trail. The old 3 Mile Island plant, not the one that was damaged, the one that was operating, was decommissioned about 5 years ago. They're
Mhm,
bringing it back. They saw us do it, so Constellation, the owner, is doing it.
mhm.
Another plant in Iowa called Van Arnold, the utility is Nextera. They are doing it. So people are following it in our footsteps.
But it would be far more expensive than setting up a new nuclear reactor, sir, a new nuclear power plant.
No, it will be cheaper. Like our Palisades plant, all said and done, will cost us, say, $1.6 billion. The refurbishment, repowering. A new plant today that size will cost 8 billion.
Okay.
So it is cheaper, definitely
Mhm.
cheaper. Uh, but it is the problem, the job is more larger than at least I had envisioned. It's much more to do, you know. We found, for example, the pipe that comes from the lake that carries water underground was badly corroded. So we
Oh,
had to dig and replace all of that piping.
well,
And not we replaced it not because it was corroded, the water was leaking. No, it was corroded to the point where now, if you strike it with a missile, it can open up. Okay, so that was the criteria.
Mhm.
So we're replacing the pipe. We replaced it already, and many such examples. We could run the plant for 2 years without doing much work. If you want to run for 30 years, 40 years, then you have to do all this.
That's pretty interesting. I mean, challenging, but
Yeah,
yes.
yes,
Anyway,
it
with
is
this,
interesting.
we come to the end of this interview, sir. It was great talking to you and hearing from you. Uh, Thank you so much for joining us.
Thank you. It's a pleasure talking to you.